So hello guys and welcome back to our YouTube channel Infinity Learning. So today we are going to discuss about the error detection and correction of LBC. So we already discussed that the syndrome S is equal to R into H transpose, where H is the parity check matrix, and we also know that the received code R is equal to the transmitted code V XOR operation E, where E is the error. So by putting the value of R in this equation, we can determine the value of syndrome in terms of error. So this will be V XOR E into HT. So this will be VHT and XOR EHT. Now, if you remember my previous lecture, we have proved this term to be 0. So S will be equal to E into H transpose, where E represents the error. So from here onwards, we will use S is equal to E into H transpose. And here a term is very much useful, that is D minimum, which is known as the minimum distance, and it is nothing but the Hamming distance. And how to determine it? It's very simple. It's just the number of ones in the bit. So this is one important term in this topic. Now we are considering two transmitted bits V1 and V2. Both are of length 7. So the distance of V1 will be the number of ones in the code V1. So there are 3 ones, 1, 2, 3. So there will be the distance value will be 3, and in V2 there are 4 ones. So the distance value will be 4. Now two terms comes into mind when we say about the transmitter and receive bits. The first one is the distance and the second one is the weight. Now we can show that the distance, actually the minimum distance of V1 and V2 will be equal to weight of V1 XOR V2. So distance of V1 and V2, that is the minimum distance, will be 3. And if we XOR V1 and V2, so this will be 1, 1, 0. This will be 1, 0, 0 and 0. So the number of ones is 3. So we can see that the weight and distance will be same. Now D min can be defined as the minimum value between the D of V1 and D of V2, and D minimum is also equal to W minimum. Now if the case goes above and it becomes for 3 variables V1, V2 and V3, there should be an inequality which should be satisfied. So D of V1, V2 plus D of V2, V3 should be equal to or greater than D of V1, V3. So there are some terms related to the error detection and correction topic which we will discuss right now. The first one is the error detection capability. By name we can easily say that this is the detection capability of an error. So this will be calculated as D minimum minus 1. This will be equal to EDC, that is error detection capability, where V1 is the transmitted bit and V2 is the received bit. In the previous example we saw that D of V1, V2 is equal to 3. So EDC will be equal to D minimum minus 1, that is 3 minus 1, which will be equal to 2. Now the next term is the error correcting capability. Now the detection we have done, now we need to correct it. So this will have the formula D minimum minus 1 by 2. So D minimum we already calculated, that is 3. So ECC will be equal to EDC by 2, or 3 minus 1 by 2, that will be equal to 1. So ECC will be 1. So these are the two formulas which we can use in the detection and correction of an error of LBC. Now there is an inequality regarding D minimum 2. So D minimum can be greater than equal to 2t plus 1, where t is the number of errors. This inequality is also very important, so we need to remember this. So we require two terms, detection and correction. So we got the detection formula and also the correction formula. Now we can easily detect an error and correct it. Now let's solve a problem sums regarding the above concepts. So here the question states, consider the following code vectors C1 given as this, C2 and C3. We are required to find the Hamming distance of C1 C2 and C1 C3, and the B part says that we are required to prove that d of C1 C2 plus d of C2 C3 is equal to or greater than d of C1 C3. So basically we are required to find the number of ones in these two combinations, and we are required to prove the inequality that we discussed above. So proceeding to the solution, we know d of v1 and v2 is basically the weightage of v1 x or v2. So we will apply this formula. So d of c1 comma c2 will be equal to weight of c1 x or c2. Now if we will perform this operation, so c1 x or c2 will be 1 1 1 1 1. So this weight will be 5. Similarly, d of c1 comma c3 will be equal to weight of c1 x or c3. So c1 x or c3 will be equal to 1 0 1 0 0. So this will be 2. So we got the first answer of A part. Now the second one, we need to prove the inequality. So d of c1 comma c2 plus d of c2 comma c3 should be greater than or equal to d of c1 comma c3. Sorry, I have mistaken. This c1 and c3 will be equal to 0 1 0 1 and 1. So this will be 3. So now this will be c1 and c2, we got 5. If you similarly find out for c2 and c3, this will be equal to 2. So, and this is 3. So obviously 7 will be greater than equal to 3. So it is proved. So you all can see that the sums regarding this topic is very simple and you can solve it very easily. Now the next topic that we are going to discuss is the standard array. Now the definition for standard array is given here. It's basically all theory part. If I read it out, you can do the same by yourself, so I will not read it out. The standard array is nothing but it is an array which will comprise of all the error values and the transmitted bits. Basically it is an array which includes the coset leader values and the coset values. Now the two new terms comes into this topic. First one is the coset leader and the second one is coset. Now we need to know what is coset leader and what is coset. Now coset leader is nothing but the vectors, the code words which have the minimum weight in a particular coset. That is known as the coset leader. So in a particular coset, or now think of coset as a particular region. In a particular region, the vectors which have the minimum weight is known as the coset leader. So now the second term is coset. Now what is coset? It's like you can relate it to the set theory part. You can see there is a statement of set that A plus C is equal to, it is a set of A plus X where X belongs to all C, where A is the vector, any vector of length n, and C is an LBC code of n comma k. Coset is nothing but a space of some elements where the elements should satisfy this condition, and we can also call coset as translate. Now this was all about the standard array. Now we can solve a problem regarding the standard array. So the question is given as the generator matrix is given and the code words are given, that means the codes that are transmitted are given to us. Now what we are going to do, we are going to make a standard array with coset leader and coset. So you can see here I have given a format of the standard array. So the first row contains the transmitted bits, and after that the first column will contain all the errors, and after the first column and the first row is filled, the second column will consist of the summation parts with the error parts. The third column will be the summation of v3 and the errors. Fourth column will be the summation of v4 and the errors, and so on. So for solving the sums, we can follow this format. So what we will do, we will give the 4 values of the bits as the first row. Now we will give the coset leader values in the first column. So this will be 0 0 1 0 1 0 0 1 1. This will be 1 0 0. This will be 1 0 1 1 1 0 and 1 1 1. So there's a question arises that how many coset leader values should be there. So you can see that the generator matrix is of dimension 2 cross 3. So the number of the rows will be equal to 2 to the power 3. This we will need to consider in every case. So this will be 8. So here there are 8 values in the coset leader. Now you can mark it as v1, v2, v3 and v4, and this will be e1, e2, e3, e4, e5, e6 and e7. Now what we need to do, we need to perform XOR operation between these two, and we will give the result here. So after performing XOR operation, this will produce 0 1 1. Similarly for the next one, we will XOR between v2 and e2. So this will be 0 1 0. For the third column, this will be v3 cross e1. So this will be 1 0 0, and this will be 0. So this will be 1 1 and 1. So for v4 column, the next element will be v4 plus e1. So this will be 1 1 0, and next will be v4 plus e2. So this will be 1 0 1. So for v2 we will XOR v2 with all the errors. For v3 we will XOR v3 in all the errors. For v4 we will XOR v4 and all the errors. So similarly, by calculating all the columns and rows, we will get so this is the required standard array. So creating a standard array is very easy, but it's quite a lengthy process. All we need to do is perform the XOR operation between all the first row elements and the elements of the first column. That is v2 with all the errors, v3 with all the errors, and v4 with all the errors. So we will get a matrix, an array of elements, which will be called the standard array. So this much for today's lecture, guys. Hope you enjoyed the lecture. If you liked the video, please press the like button and share your thoughts in the comment section, and please subscribe to the channel if you visited my channel for the first time. Thanks for watching, and I'll see you in the next one. Till then, bye bye.